Okay. Let me introduce the first speaker of the session is Artur Andrzejak, who will be telling us about virtual domain-specific languages via embedded projectional editing.
Okay, thank you for introduction. It's a pleasure to be here. And this is work together with Niklas Korz, who has done this during his master thesis. And I will be speaking Artur. So yesterday we saw during the talk about the X-space something about the advantages and disadvantages of different type of DSLs. And we know that there are internal DSLs, essentially libraries in host general purpose languages, and external DSLs, which are essentially any language with arbitrary free syntax. And as usual, there are some trade-offs, and the internal DSLs have many interesting points, like they are easy to implement, they integrate well with the toolkits, and they are compatible they can be also integrated with the host GPL. The bad thing about is that they are constrained in syntax. On the other hand, this constraint is not present in external DSL, but there is a lot of other disadvantages, including high effort to implement and low integration with tools and with the other programming languages used. So it seems like a clear vote for internal DSLs, unless you try to combine them with mainstream general purpose languages like Python or JavaScript. And then you get internal DSLs, especially in JavaScript, which are really hard to read, which do not really have a big advantage compared to the original language. And this was also one of our motivation, how to create a readable, beautiful DSL embedded into JavaScript. Okay, and after this motivation, I can tell you what we have created. So take a look at this code. It looks like a Python code, but it's actually, something is wrong here. You see here some elements. Okay, unfortunately my virtual laser pointer does not work, but you see here in this line here, there is something which looks rather like Ruby. Also, there is no increment operator in Python, and there is no things like the printing to the console using something not a function, not at least in Python 3. So this is something which is possible in our system, that you can just mix Python code with more or less arbitrarily syntax elements which you defined on your own. And in fact, just to make the presentation simple, I defined these additional elements in the yesterday, just to make this easy, more easy than what is in the paper. So what we have in this system of virtual DSLs, we have a system which allows you to free mixing of GPL and DSL code. But there is, of course, a trade-off, and the trade-off here is that it needs a special editor. It needs a hybrid editor. I have prepared some screencast how this editing in an editor looks like. So it is you can use syntax completion, and essentially you can mix here freely parts of normal code, of Python code here, or the DSL code. And what you get here is essentially an experience which is very close to textual code editors. I don't know whether any of you have used tools like MPS, JetBrains MPS, which is a language workbench projectional editor. You probably know that editing there is hard because it does not feel fluently. We tried to essentially create an experience of textual code editor by inserting parts in your source code which are non-text but feel like text, and all others are essentially all others are textual parts. Now, maybe the interesting thing about this, that while you are editing, internally the hybrid editor maintains as the only representation of code the actual pure source code in pure Python. And this is something which is also serialized. So in our hybrid editor, there are no additions or extensions to the language. And when you serialize this, or when you use tools like code checkers via language server protocol, you can immediately apply this because everything is pure Python. Only the representation for the user in some parts is your DSL. Okay, and indeed you can even, and you see, you can even in a screencast edit this simultaneously. And when you look at the live demo, which the link is is shown in the abstract of the paper, you can simultaneously edit the projectional form or the hybrid form on the left, and the source code will be created. And also when you, for example, something is wrong in the syntax on the right side, the projectional form will be reverted back to the source code. Okay, so this should give you the idea of the artifact which is produced by this paper. And in addition to this, there are more examples which are mentioned in the paper and also in the source code, which is attached to this paper, and you can see them. Just wanted to get to a moment where I change here something, I make a mistake in a syntax, and then you will see that on the, I changed there on the right side, and you see immediately we get here the original source code as a fallback. Okay, so you can edit both parts, and this is still working. So other examples are here. In addition to these textual parts, you can also add kind of arbitrary graphical widgets as your projections, as your part of the source code. And you can also use other programming languages as JavaScript. Okay, so how does it work? So essentially the representation in the hybrid editor used something, a collection of DSL elements, and DSL elements consist of a pattern and a projection template. And the pattern essentially is a matcher for a specific part of an abstract syntax tree in the original source code. Here in this example, we are matching part of Python code of this type, and the projection template is a web component, in our case Svelte web component, which represents this and also allows for editing. So the whole virtual DSL is implemented for a specific case, for your specific DSL, as a set of such DSL elements, and then you plug this into a hybrid editor. The hybrid editor is taking the source code in Python or JavaScript or any other language and tries to match the individual patterns during the editing in the source code. For each of such matches, we then extract parameters. For example, in our, I go back, when we extract here in this, for index in range, we extract here index and we extract n. So they are the parameters which are extracted by the pattern. And these parameters are then passed to the renderer, to the hybrid editor, which takes these parameters and essentially plugs this into a web component. And in this case, it's text, but it can be even a diagram, it can be something graphical. And so we are essentially, for each DSL element, we are matching the corresponding AST part in a source code. We are extracting the parameters. We are taking the web component, rendering this, And then when some edits take place, we are updating back the AST, and then the whole cycle repeats. So during the editing, essentially, no matter whether you edit the source code here on the left, or whether you edit this using the the GUI interface, you are always immediately update and get the newest version of the AST and internally store this AST as your only representation of code. Okay. So I will not get into the details of the pattern matching. There, essentially, you can think about this traversing AST3, and then you are trying to match the patterns and then extract these parameters. So an interesting thing maybe is how we define these patterns. To make it easy for a DSL developer, we are just taking a piece of code in the target language. It can be JavaScript, it can be Python, or any other language, and we are enhancing this with few function calls which extract variable parts. And the most important variable part is argument, which essentially extracts a variable or something like a string, and a block, which essentially allows you to nesting of these projections. So in this example, when we are extracting, we are here having a piece of Python code, and if I would like to define a pattern for this, the whole code which I need is this. This is code in TypeScript, but the essential parts are these red lines, which are Python, and within this part, you see that we have three essentially parameters. Two are extracting the variables, the third one is the block, and by parsing this, we get a pattern which is then matched during the editing. Okay. The second part which you need to define a DSL element is such a Svelte component. So there are different ways to do this. The long form is essentially writing more involved Svelte code, but for textual simple forms, you are essentially use code like this, where you have a list of variables extracted by a pattern and the constant parts. Okay. Now, even if writing of such DSL elements, I would say, is rather simple, we still tried to make it even easier and make an approach for automatic generation of this patterns and projection for text cases using samples, such samples like this here. You see one line of JavaScript and then one line of textual projection representation, and the user or developer, DSL developer, essentially gives a set of such pairs, and our algorithm tries to generate the correct pattern and then correct also the presentation, textual representation of a projection. Here in this case, it would look like this, a little bit simplified. And I will not get into the algorithm here, but you are doing this essentially in the following way. You are looking at the pairs of source code for which you try to generate the pattern, and you are looking which parts are common and constant and which are variable. Okay, so here you see we have two examples of source code, and the highlighted parts are variable, the reminders will be constant parts. You do similar process for the examples of the projection which you want to get. Here they are underlined, and then finally an algorithm tries to match these variable parts extracted in both parts. So this is a very limited form of programming by example or program synthesis, but it's really very, I would say, specific and constrained. Okay, so in the last minutes, what is the related work, other approaches by this? Of course, there is a huge amount of work on projectional editors and language workbenches, but here there is we wanted to make it closer to textual editing, and there is also a lot of work on textual editors which enrich the editing experience with some graphical elements. And the reviewers have pointed out to us some of the works, and then we later found more. And I would say if we knew this before, we probably haven't started this project because there's already quite a lot of related work. I will not get into details. However, the essential parts of this related work is that they are focusing on functional languages or using more special extensions, syntactic extensions, which needed also the specific languages. In our approach, we targeted instead of mainstream popular languages like JavaScript and Python, and one of the premises was that the GPL should not be changed in any way, so that the whole toolkit, tool chain, including linters, other IDEs, static code checkers don't need to be adapted. So another important thing is that I think indeed creating these DSLs is pretty fast. You can do this incrementally. The elements which you use in your hybrid editor do not depend necessarily on each other. So you can essentially incrementally say you start with a small DSL, and within hours you can enhance it according to your needs. And finally, we can, this all is web-based. The basis for our editor is called Mirror 6, which integrates, for example, out of the box with Jupyter Lab. And also our next target will be to look at integration with Visual Studio Code, which should be also possible. There is the web view component in Visual Studio Code which allows this, and also improve further the DSL, the pattern and projection generator. Anyway, I think the best thing is to open the web browser and play with this a little bit and see whether it could be interesting or useful for you. Thank you very much.
Okay. Questions?
Hi, thank you for the very interesting presentation. Could you give some more detail on how one actually specifies the let's say the grammar or the structure of the DSL? I saw the example based, but it's not entirely clear to me how one defines one's own.
So essentially what you do here is you are creating a piece of code which you want to be matched. And normally if we wouldn't have this extrapolation things, it will be a constant string. So not much, not very useful. But then you are adding these essentially variables, and they are matched by corresponding subtrees in an AST, depending on specifications. For example, should it be an identifier? Should it be a string? Should it be an other type of node? And when this is parsed, this is essentially, here you see the Python parser. So this is TypeScript, but we are calling a Python parser, tree-sitter parser for Python, and we turn this into abstract syntax tree, where some nodes are special. And they are special because they do not match literal values, but they are match values according to specifications, like, for example, identifier, etc. And that's essentially pretty easy to do for the DSL designer. Of course, it has some constraints. For example, one of the constraints is that you cannot match different parts of code. It must be, everything which you match must be described by a single subtree of an abstract syntax tree.
Thank you.
Hi, I'm Eric Eide from the University of Utah. I enjoyed your talk.
Thank you.
So actually, while you were describing your system, somewhere in the middle there, I said, this sounds a lot like presentation extension by Eisenberg and Kixalis, which you cited as related work, right? So I had to quickly grab the paper and see if you had cited that work, and you did. That was great. And in the related work, you described a primary difference between that past work and your system as the fact that presentation extension relies on an annotation, a code annotation, to say where the presentation extension should apply, right? I want this little bit of code rendered as a button or a color or a fish or whatever, right? And you said, yeah, and yours doesn't, right? You just match on the code. And I was wondering if you wanted to say a little bit about that choice, right? And it just, I guess one consequence of not relying on an annotation to say where the extension should apply is that anytime the user essentially accidentally writes matching syntax, right, it will be projected into the DSL, even if that isn't the user's intent.
Yeah, that's actually a very good point. Thank you. And this happens indeed that sometimes I edit something in the hybrid editor, and suddenly I get a like intermediate form which I don't really want. Well, the choice why it was done is because we don't want to make any burden or barrier for adoption of this. So one of the use cases you can think about is just reading code, where people are having involved constructions, for example, in JavaScript, things like asynchronous programming and these continuations. This is sometimes very difficult to decode. And this gives you essentially, without the need to annotate large code base, helps you already to present this code in a nicer way. On the other hand, of course, we could, it would be possible to add annotation and say don't, you could have like exclusion annotations. Yeah, you could say don't represent this in this way. But in any case, you can always revert back to a normal source code editor. And in fact, what I showed that you can edit this and see this side by side. We will do this the same in Visual Studio Code. The normal Studio Code, the normal thing, the normal code will be shown. And in addition to this, a hybrid view. But I think we need larger case studies and talking to developers, in which cases this could be indeed a handicap. And I think that there might be some situations.
Thank you.
More questions? Yeah.
Thank you very much for your presentation. I have a question which is in some sense a follow-up to the previous question. And I think an important aspect of your work is that you can present different views to potentially different users of the DSLs, or essentially have different DSLs that translate into the same underlying language. So my question is, have you considered that perhaps a pattern might be, so there might be multiple rules that involve the same pattern? In other words, there may be multiple elements of your DSL that translate into the same underlying syntax. So that could be considered an extension of the previous point, that perhaps in some case you want to present the original source syntax unchanged, and in other cases you might want to translate into this, into another DSL component. But what if you have multiple such components, multiple ways of representing the same underlying source code?
Well, I think this is something which is a little bit related to these projectional editors, which allow you to represent, to show code in a different ways, or as a table, as a normal code. I think that the user would essentially have a kind of switch which says, I prefer this view, or open just another view. And indeed, you can essentially instantiate multiple versions of the hybrid editor with a different set of DSL elements. And depending on your need, you can see this in one or other way. I don't think it's a problem, it's rather a feature. And indeed, I think that if we make a larger use study on real scenario, a lot of aspects like this will come up and show us what is really needed.
Indeed. Thank you very much.
I have a follow-up question to that. So on the example that you showed, there was this plus equals thing. that actually in some cases it was converted to ++. And so, yeah, that one exactly. So if we change plus equals 1, oh, that's a bit weird. Yeah, so yeah, you can see that it's plus on the left side. And when we change 1 to 2, it's going to be plus equals. So there could be actually cases where we want to kind of specify priorities for the matches. That, just take the kind of more restricted version, for example. Or, for example, in this case, I don't know, plus equals could be translated to update unless it's plus equals 1. So we want to first check that, okay, if it's plus equals 1, do it plus plus, otherwise do it update. So is there any kind of the mechanisms behind it supporting that kind of thing, or?
I mean, in our current implementation, you are just trying to match a first pattern. So you make sure that at most one pattern matches. If several match, you just you order them by length. So there is some strategy to resolve this. But indeed, there could be some kind of prioritization. It's not difficult. And when you say, for example, +2, and here the projection does not apply anymore and the original source code is shown, you could have alternative pattern even in a current system where just says, okay, if you show +2, then some other projection will apply. But you can, if there are multiple matches for the same source code AST part, you could have a priority. That's not difficult to implement. And yeah, I think that with this usability things, there must be some kind of gathering some experience over some time and see how people, what people like and what really works well. Yeah, but it's interesting point too.
Is there a final question? If not, I have a final question before we change. So what you're defining here, your templating language reminds me, well, it looks like a macro language, so I was wondering if you provide hygiene.
No, unfortunately not. and this is, of course, yeah. For example, like I was looking at the projection or DSL element for swapping elements. Okay, in Python you can do this with a temporary variable, but indeed something like this would be also needed, that you are introducing this. However, this would make very difficult to take source code and match to the projection, where you start with a projection and like shown in example that you insert them in a hybrid editor, this could work. The other way around, you must be agnostic to the name of the variable, etc. It's possible, but the pattern would be more involved and probably not possible with the current state of the implementation, because you must essentially ignore the name of such variables or the order or things like this. Yeah, but it's definitely something which also needs some further attention.
Okay, let's thank Artur once again.